just asking, are we full now? Or are there still a couple of people coming? There's just one. So shall we start? Shall we wait? Start? Okay. All right. Good morning and welcome to this study design session. My name is Martin Kainz and I work at the Danube University and I teach scientific working, scientific writing, and I also teach at the University of Vienna food web analysis. I'm a biologist by training, and the last couple of students come now. All right. So I'd like to give you a brief overview of today's schedule. I'll give you a rather long overview of the research study design and evidence-based studies. This will be extremely important, I think, for medicine in general. I give you basics about statistics. First question, who does not have any statistical background? Don't be shy, don't be shy. One. Okay, both your hands. All right. I tell you then also what I do and what I cannot do. We only have a few hours today. I cannot give you an introduction to statistics. Okay, this takes years and years and years, and I'm not kidding. You know, this is really takes a long, long time. Basic statistics means really basic statistics, so understandings of terminologies and so on. I won't go, maybe in the afternoon then, about statistical testings. And I screened over the weekend and yesterday a few papers that the orthopedic journals have, and so I can refer to those. After coffee break, we go on with research planning. Then we do take a lunch break, and then we use the afternoon basically about how we think about, how you think about research in your specific fields. Okay, so I would like to take this opportunity that you talk, you have questions, and we talk about that. How to read papers. Reading a paper is not just like reading a newspaper or a book. Okay, it's a different method. We are going to learn that. And then also how to write paper. Again, as with statistics, you know, we cannot, and simply it will be beyond the scope of this class here. I cannot teach you how to write a paper today, but I can at least give you some hints and prepare slides to understand how to read, how to understand, how to scrutinize papers. All right, so let's jump into the research designs. Okay, so before we talk about research design, we should be clear about what scientific research is. Okay, and when we think about scientific research, we must think we have to come up with assumptions. The first assumption is that all we see, you're all orthopedics, right? Without any exception. All right. So an Achilles tendon, okay, is in every human being, right or wrong? Right. Right. Is in every animal. Right or wrong? Wrong. Why? In mammals. In mammals, yes. Good. Okay. First thing is be critical. Don't believe what you read. Okay. So if you read in a paper all animals have Achilles tendons, then you're absolutely right. First plus. Good. Okay, so be critical and let's always scrutinize and examine very carefully what we are thinking, what we are learning, what we are reading, what other people think that you should believe. And this is the first term that I would like you to cancel at least for today. One term in science should never exist, which is believe. Because I can believe something and you believe something else. And that's not subject of science. What you say, I must understand. What I convey, you must understand. If I say 1 plus 1 equals 2, everybody needs to agree on that. So you need to be able to replicate whatever we say. Okay? So this is not about belief, this is about knowing. It's just the intersubjectary understanding of what we do. So if we can prove, if there's evidence that 1 plus 1 equals 2, then we can agree on that. All right? We don't need to believe it. We can agree on that. So these phenomena, and I call them natural phenomena, can be measured. Okay, so the Achilles tendon can be measured. The bone length can be measured. The growth of a bone can be measured. The fracture of a bone can be interpreted, can be measured, can be seen. If there is a bone bruise, I don't know, on the leg, you can measure that with MRI, and you can see how long you can see that. Okay, and you can discuss that, and you can say that's it, what we have, and that's still a bone bruise, and now it's over. We don't see it. There's no evidence anymore based on imaging that this bone bruise is still around, for example. So it can be measured, it must be measured. Everything that we do in science must be reproducible. If you come up with a study, you must take notes of how you did this study. So we must understand the methods of your studies. If you read a paper, you must understand what the authors did. If they don't write exactly what they did, but come up with results of which you have no idea where they come from, that is not a good study, to say the least. Okay, so we must understand what people did in order to reproduce the studies. Okay, same thing is in the hospital. You know, if you use an MRI technique, you must use the same technique for the same symptom, for example, unless there is evidence that other techniques, other methods are better. And we do that because the events or conditions have one or more causes. Okay? So if there is a phenomenon in science that you try to understand, you must know the methods that yield the result. There can be also a different method. There can be also a statistical method, for example. I name now a student's t-test versus an analysis of variance. If you have two groups, you can use both methods, statistical methods. They will result exactly the same. If you've got three groups and you use both methods, then it's wrong. Okay, so you must always understand what the method is, and this must be reproducible. This is the basic, that's the baseline, that's the fundament of scientific research. Then we've got methods. These methods are defined as systematic, empirical, controlled and critical examination of hypothetical propositions about the association among natural phenomena. I always report some references at the bottom whenever they're necessary. So methods need to be systematic, they need to be logically constructed, empirical, controlled, and critical for the examination of hypothetical propositions. Every research must have a clear objective. In every paper you read, you must find what the goal, what the scientific objective was. In a very good paper, you can also read what the authors hypothesized. So what was the expectation based on the research that they conduct? Okay, so an hypothesis is an assumption how you think a system responds based to the treatments you apply. All right? Okay, so what do we mean about systematic, empirical, controlled, and critical? Systematic is the use of logical procedures to ensure reliability. the logical sequence is used, or any logical sequence is used from problem identification through data collection, analysis, and interpretation. So these are systematics. All of these methods need to be written up, okay, so that you can understand what these studies were about. Empirical means that all empirical studies need a documentation of the objective data through direct observations. Okay, so this is essential. You need to document. You need everything that you measure needs to be documented. Findings are grounded in the objective observation of phenomena and never subject to personal bias. This is especially for people that start scientific research, and I'm being very frank, okay, so which is good, I think. In medicine, a couple of weeks ago, somebody asked me, PhD students asked me, well, if I do a PhD study now, I cannot take my personal observations and base these for my studies. I said, yes, you can. But at the same time, you should not use any reports, any newspaper articles, any reports that are written in any non-refereed journal, okay, and base your knowledge on this kind of, under quotation marks, knowledge. Every science must have been reviewed by your colleagues, by other scientists, before these studies are published. So we are only talking about peer-reviewed journal publications, okay? No notes, nothing that you think or you believe that an Achilles tendon injury can be healed by drinking water and that's it. If you believe that, okay? This lacks scientific evidence unless you have got a number of papers that reproduce the same result, that subsidizes your assumption or your argument that drinking water, lots of water, heals, I'm just saying, Achilles tendon inflammation, for example. So never use your personal opinion when you perform any scientific research. We need, in any scientific method, we need control. Okay, what do you mean? What do we mean by control? We need to understand how one phenomenon relates to another. Factors are controlled that are not directly related to the variables in question. For example, if we have, this is a little bit unfair today. Normally we have got two equally distributed groups, but let's say that this group on the left-hand side is a control group and you're the working group that is subjected to some phenomenon, for example, teaching. If we were to say, and we come to that a little bit later today, but I'm already making that clear what a control group is. You all came in at the same time, you're all at the same profession, and for example, sorry guys, you don't listen now for half an hour, okay, about research, and I prime you, I teach you about research now, let's say for half an hour or one day, doesn't matter. And I examine you before we talk about that, okay, I examine all of you, and then we want to test the effect of teaching. It's clear. The effect of teaching can only apply if you have been around. But we don't know if you score better than others if you don't have a control group. So obviously we need to exclude the control group and you score them. Now this is in theory okay, but what's the problem? The problem is that maybe some of the colleagues here won't score as well as these guys. Okay? So if that is the case, then we need to perform statistical analysis, which we're going to do later on today, to see if teaching has what we call a significant effect to improve your knowledge, okay, relative to the control group. And this is a little bit more complicated than we think, because if we have got one person who scores way worse than all of the control group, it doesn't matter, provided that all of the rest is scoring better than the control group. And there's statistical tests that can control for that. And this simple example applies for everything else. So if you're going to do an analysis of in your field, you need always control groups. And there are different kinds of control groups that we're going to discuss today. But we need that. For example, if a patient comes to your office and says, how long does it take for the callus to form, you can only relate to what you learned at school, at the university, or out of your own understanding, right? But this does not necessarily apply to this one patient. This is very clear, okay? So therefore, we need to understand what kind of effect does a certain treatment have on a certain population relative to a control group that does not obtain the same treatment in this case. Okay. I tried to relate to the following topics a few examples so that it becomes a little bit more plastic. When we talk about research, we have not only one type of research. As you know, you also have not only one type of examination. There are many types of examination. That's the same thing for scientific research. So what we can discriminate is descriptive research, exploratory research, and experimental research. And all of these research types are relevant for your studies here. So the descriptive, and I'm going through that point by point. Descriptive research includes case studies, cross-sectional studies, and qualitative studies. The exploratory is a cohort study and a case control study. And the experimental study can be a true experimental study design or a quasi-experimental study design. All right, so let's go and let's first talk about exploratory research. We talk about exploratory research when the investigator examines a phenomenon of interest and explores its dimensions, including how it relates to other factors. So proven relationships between a phenomenon and other factors can lead to predictive models. Can we come up with an example for that? So for those guys that do not have any statistical background, I think it's pretty clear. And we know that from mathematics, from high school. This is a predictive variable here, and this is the response variable. Okay, so if I was driving in from Vienna this morning, and if I put my foot on the throttle very, very hard, then I go faster, and this would be the fuel consumption. It's very clear. Okay, so we get the more gas the faster I drive, the more gas I will use up. The same thing the more sport an individual does, the healthier it may become, the individual. So this is exploratory research that tries to get to correlational studies that explain a phenomenon by one predictive variable or by more predictive variables. Okay, that's very clear. This is something that you can do at home. You've got patients, and these patients heal differently, and you try to understand what the speed of healing, how the speed of healing can be explained. I don't know. This is your field. I'm not an orthopedic. yeah, I can imagine that activity, for example, can be good for back pain. Should be around, the other way around. Activity is good to ease any back pain, for example. Okay, so and if you try to do an analysis and say, okay, try to encourage your patients to do more activity and count that, okay, or the length of the activity, and then try to do some exams if the back pain eases. This would be, for example, a clear correlative study. This can be also the other way around. A predictive variable can also decrease. For example, you increase the predictive variable and it can lead to a decrease in response. Okay. For example, alcohol consumption increases and survival or liver damage, or the health of liver would decrease. Survival would decrease. That's very clear. So this kind of predictive studies can be can go in all sorts of directions. These, what we call here, are linear regressions. Okay, these studies are linear regressions, and they underlie certain assumptions again. It's different when we look at this kind of correlation here. How would that? Can this happen? Or how can that happen? That the predictive variable, okay, increases steadily, but the response does not increase in one direction. Can we come up with an example, for example, here? What was that?
Like the power we put on something and the deformity has.
Right.
There's a stress point and then.
Exactly. So, what can we learn if a predictive variable increases and yields such a response?
It means that it has a limitation until that value, it has a good response, and after that it has
a negative response.
For example, a drug till one dosage, it's good for you, and after that it's bad for you.
That's exactly what I was after. Exactly. And this is just an example here, but the response does not need to be linear, okay? So that is very important, that the predictive variable, if it increases, it can have also an adverse effect in terms of the response. That is extremely important to realize. Okay. The experimental research in general provides a basis of comparing two or more conditions. Okay, it controls or accounts for the effects of extraneous factors, providing the highest degree of confidence in the validity of outcomes, enables the researcher to draw meaningful conclusions about observed differences, and randomized controlled trials, single subject designs, sequential clinical trials, evaluation research, quasi-experimental research, and meta-analyses. This is something that you can read then at home. My question is, did you already get this information, all these slides? No, you will get these slides. I sent them yesterday. Maybe it was a little bit too late in the evening. So you'll get those, and okay, so you didn't also get the papers that I sent out. But I sent out 3 papers yesterday that we're going to talk about this afternoon. Is there a way that you can get these papers? Like, is there anybody who is in contact with the people at the university? How do you normally get class material?
We can make by email PDF.
By email. By email. All right. Okay. During coffee break, I'm going to phone up people that you should get.
Yuri will be here in 30 minutes. I think that during the break we can have a chat.
All right.
How to manage this.
Oh, good. Excellent. Good. So that's the experimental research. This is what I was referring to now. This afternoon we are going to talk about 3 papers that I picked yesterday for a couple of reasons. First of all, they all deal with Achilles tendon rupture or problems in general. And if you look at the publishing dates, this is 2016, 2010, if I'm not mistaken, and certainly 1971. It's an old paper, and we are going to examine these papers in an effort to understand how to read papers and also how to scrutinize these papers. Okay, we come to that a bit later then. Okay. When we talk about descriptive, exploratory, and experimental studies, this is a chart that I copied from a book, and it's pretty informative, I think. So this means what a descriptive study does. It describes populations. It deals with case studies. It can, all of these, can include survey research, qualitative research, correlational research, evaluation research, secondary analysis and cohort studies, and historical research is true for all of these studies as well. Exploratory studies, they define relationships. This is exactly what we just said. And experimental studies are only after cause and effect. So this is something that if you do in the hospital or in your home office, and you look at cause and effect relationships, this is experimental studies. We can also do that when we look at a study design in the peer-reviewed literature. We only look for evidence-based research. This is what we call cause and effect research. And we're going through all of these now. How do you know what kind of methods you choose for your own studies? How do you know if, when you read a paper, the method that these people used, the authors used, is good, is the appropriate method? This chart can help finding that. So here we've got the advantages listed, and here we've got the methods listed. The existing records, focus groups, interviews, what can you do with observations, what can you do with a portfolio or journal examination, what do tests do, and what do written surveys do, and what's the advantage of these. And here we find the response. So we must understand that if we do, for example, what do we do here? Tests, okay. The advantage of tests in general are that they're anonymous, they can be cost effective, easily administered, generalizable, and quantitative. What is very important now, what I said before, is that research needs to be generalizable. Okay, we need to apply the research methods that we get through our own research. For our own research, we must scrutinize it. We must also be able to replicate the research. Okay, so for example, is an observation replicable? If we observe, for example, let's stick to the Achilles tendon problem. In an example, in Vienna at the marathon, after the marathon, we had 100 people that had Achilles tendon problems. Okay. 2017, 100 people, 50 males and 50 females. Can this study be replicated? They have all severe problems. Can the result be replicated? Can the result of 100 Achilles tendon problems after a marathon in 2017, and 50 females and 50 males are affected, be replicated? Why not?
Because it depends on what people are attending in the marathon, age, their health status, and maybe their 60, 40, 30, 70. It depends. It cannot be 50-50 each time. I think.
Good. Is this a study, what I just said? Can people that did not lament about Achilles tendon problems be used as a control?
No, they hadn't. They didn't run the marathon.
No, also they ran, but they didn't have any problems. Can they be used as a control?
No, there are many variations, so they cannot be the same.
Okay.
There should be no other variables so that we can compare them.
Okay. So
Or we
is the observation that after a marathon, 100 people suffered from Achilles tendon problems, can this observation be called a study?
An observational study.
Yes.
You say yes? Why do you think yes?
Because if 100 is going to maybe jogging or marathon and 100 no, that means that if you go to that, you can have that problem.
All people ran the marathon, okay?
Like you have the control, that means
Let's say 1,000 people ran the marathon, okay? 100 report problems with the Achilles tendon afterwards. Is that a study? Think about that. I don't tell you the answer now. You tell me the answer before lunch, okay?
What are we studying? Which is a question.
Oh, you're already ahead of time now. Absolutely right, yeah? But, okay, the observation itself, an observation itself is an observation. It's not a study, okay? It may be very simple to you now, if I say that. Science is not always very complicated, it's just logical, step by step. If we don't have a question, if we don't have a clear objective, if we don't have an hypothesis to test, but the mere observation, then we have an observation. An observation by itself is not a study. Okay, it's just an observation. I know that after the marathon, there are 100 people that suffer from Achilles tendon problems. Fine. If it were 80, it were 80. If it were 1,000, it were 1,000. If all of them, then it's a problem. If I don't know how many thousand ran, but if all of them had Achilles tendon problems, then they all ran probably barefoot or something. But it's a problem then, okay, but it's not a study. It's just an observation. Okay? It's very important. And you must be really clear about what is a study and what's a mere observation. Okay? Okay, now we go to this. Yes?
What do you mean by observation?
An observation, again, an observation.
A study, I think if you give some conclusion after observation, it could be a study.
Okay, what's the conclusion of...
By observation, you can get some results which can affect treatment or other things, which can be the proof for something.
Okay, now we have got many things mixed up. It's good that you mentioned that. Observation, proof, helpful for treatment. Okay? Observation again. I like the phenomenon of marathon because it's, and Achilles tendon because it's a common problem. 1,000 people ran the marathon. 100 people report Achilles tendon problems afterwards. That's an observation. We had no questions before. Okay? The proof is not in proof. Is it a proof that the marathon caused an Achilles tendon problem after for these 100 people? Is this a proof that the marathon was the problem? No. So therefore, the proof is cancelled out. We cannot say it's a proof. Why can't we say it's a proof? If 10% of the participants suffer from Achilles tendon problems after the marathon, why can't we say that running a marathon caused the Achilles tendon problems?
You can observe this 10% and see what was wrong with them, what special.
We don't have control group.
And what also don't we have? We don't know the conditions of these 100 people before. Okay, so we don't have a pre-test, we only have the post-test. Okay? Exactly. In other words, I'm using these examples, please don't replicate them, but it's very clear. People are stopped by policemen at midnight. One driver, okay? Well, let's see, 10 drivers, 10 cars, 10 drivers. All of them are drunk. And the policeman says, okay, where did you come from? They say, well, from the pub over there. Okay. Can the policeman say, not that it matters, but would the policeman have evidence that they got drunk in the pub? No, they could have been drunk before. So, that's the third point that you raised. How can we treat the problems? We first need to know the cause of the problems. That's exactly what I said here. Cause. Okay, there's no battery. But cause and effect. Okay, that's what we need to understand first. Is there perhaps a new battery? Haben wir eine neue Batterie da vielleicht so drinnen? Vielleicht irgendwie. Okay, so we go now to descriptive research, case studies, cross-sectional studies, and qualitative studies, and I explain them. The strength of the case study design is to enable understanding of the totality of an individual's experience. It's also an in-depth examination of a situation or case that leads to discovery of relationships that were not obvious before. What we just said about the Achilles tendon problem are useful for generating new hypotheses for describing new phenomena. We have no control group, it's prone to selection bias and confounding, and it limited generalizability. That's exactly what we, vielen Dank, danke sehr. That's exactly what we said before. So that's the let's call it weakness. A cross-sectional study, for example, what is the prevalence of chlamydia in women age 18 to 35 in Vienna, and is it associated with the use of contraceptives? Okay? So, this would be a cross-sectional study. What is the prevalence of chlamydia in women aged 18 to 35 in any city, in this case in Vienna, and is it associated with the use of oral contraceptives? What do we assume when we ask this question? That there is a prevalence. Right. Before we assume there's a prevalence, we assume that there is a relationship. Right? Okay. So, how would we be able to term this relationship differently? Not what is the prevalence, but does the prevalence of chlamydia in women increase with increased use? Okay? Because with the use, we need to know what kind of use. Is it once, twice, 3 times, increased or decreased use? Okay? We need always to ask a question that we understand how we think the system responds. Okay? So, if we go faster, our heartbeat will go faster. If we go slower, heartbeat will go down as well. In general. That's an hypothesis that has been tested millions of times. Okay, so how would we be able to do that? We could go, for example, select a sample of 100 women attending a sexually transmitted disease clinic in the city of Vienna, measure the predictor and outcome variables by taking a history of oral contraceptive use and sending a cervical swab to the lab for chlamydia culture. So a questionnaire may be used to gather information about oral contraceptive history. Okay? So this could be done. We could not even tell the people, although we need to do it for ethical reasons, we could ask the people, okay, you've got chlamydia in your throat, in your mouth, and can we take a swab? We take that, and we can also try to see if there is contraceptives relationships. This can be done. This is a cross-sectional study. Okay? The strength of that is, it is rather fast and inexpensive. We have no loss of follow-up. It's ideal for studying prevalence, and it's convenient for examining potential networks of causal links. So the analyses examine age as a predictor of oral contraceptive use, and then examine oral contraceptive use as a predictor for chlamydia infection. The weaknesses, however, of such a study are difficult to establish causal relationships from data collected in a cross-sectional time frame. Lack of temporal relationship between predictor variables and outcome variables does not establish a sequence of events, and it's not practical for studying rare phenomena. We need to... Oh, this is okay. You don't have a question? No, okay. This is the strength and the weaknesses of that. We see now that we need to be careful, and this we go on and on and on. We need to be very careful with all methods to understand if the methods we choose are appropriate for the studies we plan. Okay? So we must understand the weaknesses, and the role of scientists is to limit the weaknesses. How can we limit a weakness? How can we limit, for example, a causal relationship. You know, if you say we go to investigate 100 women between 18 and 35, and we'd like to understand if the use of contraceptives increases a chlamydia infection. How do we know that there is a causal relationship? How do we know that?
We should have more variables, like have you taken oral contraception for the last 16 months, or put some boundaries in order to filter the choice of subjects.
Exactly, exactly. So what we need to be sure about is that before we study that, we need to know the weaknesses. And our responsibility is to limit these weaknesses. As you said, what are the weaknesses? How can I get rid of these weaknesses? I can do that with a questionnaire. I can do that with further exams. Or, number two, I am aware of these weaknesses and I cannot limit these weaknesses. Okay? So if I can't limit these weaknesses, what I need to do is simply I need to be honest about them. And I say, in the conclusions, I show correlative evidence, not causative evidence. Correlative evidence. Okay? I need to term it this way. I show correlative evidence that there is a relationship, a positive, significant, and we talk about these relationships afterwards, relationships between the contraceptive use and the chlamydia infection in women in Vienna in 100 women in Vienna aged between 18 and 35. This can be done. This is very good. So we have to be always aware of these weaknesses, and two things we must remember. Get rid of the weaknesses before you do this study. That requires that you plan your study well ahead of time, and this is what you need. You must do that anyway. And if you then realize that you cannot get rid of these weaknesses, you must report them. You must report that these are natural limits. Okay? Qualitative studies. Qualitative studies, what are they? They seek to describe how individuals perceive their own experiences within a social context, emphasizes in-depth, nuanced understanding of human experience and interactions. Methods include in-depth interviews, for example, direct observations, examining documents, focus groups, and data are often participants' own words and narratives of observed behavior. I am not a keen fan of these things because they are all a bit wishy-washy. They can be important, they can be necessary. Personally, I'm a natural scientist, and natural science does rarely do that. But there are cases where you need to do that. Okay? For example, a researcher wants to understand how provision of health care to undocumented persons affects the people of institutions involved. So we have got in 3 communities, information is gathered from undocumented patients, primary care clinicians, specialists and hospital administrators, and the methods could involve in-depth interviews, key informant interviews, participant observations, case studies, focus groups, and so on. So you try to understand what people think, how people perceive healthcare. Okay, so we are there in the old monastery. I think this town here doesn't have a hospital, but people can say, well, this is healthcare in this town. Are you happy? And they can say, what do you normally answer when I ask the question, are you happy? Yes or no? Now, is that very informative? Does it explain something?
It doesn't explain, but it may give you a perspective of how people think or do.
Okay, but if I were a nerd and said, okay, I don't care if you're happy or not, the healthcare.
Yeah, but if you use
But that's not related to the question I'm asking now. I know what you mean. But if I'm saying, what's wrong with the question, are you happy with the healthcare system here in Hamburg?
Because it doesn't explain, it doesn't give justifications.
It doesn't explain. It is not designed to provide an causative or explanatory answer. It just gives you a yes or no. So this is, dear colleagues, this is one of the most important sentences of this day. Please tell them also your colleagues that have been, that are out now. I repeat that anyway, I hope. Never ask in research a question that requires only yes or no as an answer. Are you happy? It's a nice question when you sit in a coffee house and say, are you fine? And they say yes or no. You don't expect more answers. If you'd like to understand how things work, then you cannot ask a question that only requires yes or no. Always ask questions. Try to formulate questions, research questions, that start with what kind of word? What kind of questions? What? Why? I thought that I'm every time I ask this question, people say first why. Why are you happy? Tell me, why are you happy today? What makes you happy?
You can't answer this.
No, you can't answer.
Explain your happiness.
What makes you happy? Mm-hmm.
Then you can make some kind of a link. Let's say most of the people makes them happy with jobs.
Do you understand how things work then?
Well, we can say that health makes people think that they're happy.
I have heard one word before. One question word. That is not why and not what, but how. Okay? How do things work? If you were now a patient of yourselves, okay, you would be interested in understanding how your problem can get resolved. And if you're a naive person, I'm saying it very clear that we understand the differences. I could come to you and say, well, what do you suggest to heal the Achilles tendon problem? And then you can brag about your knowledge and say, oh, I know this laser technique and I know this and this and that and this may work. And oh, great, fantastic, it may work, fantastic. This is really great that it may work. If I were now an initiated patient and I come to you and say, what are you going to do? You say the same thing. And I'm asking you now a really good question that puts you on the spot and say, how are you going to solve my problem with the Achilles tendon? And then you need to think about the method that you apply in order to answer my question. And in fact, to answer your question. These are the only questions that you in your professions have. How to heal people. That's the quintessential question of any medical doctor. And this is the basis of why we get a better understanding, based on research. Okay? Well, I'm just talking about the research that helps better understand how you can treat medical problems. And that all requires knowledge of processes. Okay? You need to understand in which way your, as we said before, your predictive variable will cause any response. Okay? If you provide antibiotics, then you may kill a whole range of bacteria, and you may cause other problems in the body, but at least you killed all the bacteria. Okay? You know how, you must understand how things work. Okay? And this is the basic questions in research. Okay, in qualitative studies, again, if you ask, are you happy with the waiting times here at the doctors, they can say yes or no. If you ask, how would you like the system to be changed, then, and you don't say 1, 2, or 3, but they need to write then, okay, then you can understand what people are really willing to, or what they're expecting, okay? It's difficult to interpret then, but at least you get a causation, an answer that provides causative answers. Okay, now the qualitative studies are useful for studying limited numbers of cases. We already said that, and provides understanding and description of people's personal experience of phenomena, can describe in rich detail phenomena as they are embedded in local contexts, and so on. And the weaknesses are knowledge produced might not generalize to other people or other settings, so it's rather restricted to only the people here in Hamburg, for example. It's difficult to make quantitative predictions. It might have lower credibility with some administrators and commissioners of programs, and takes more time to collect and analyze the data when compared to quantitative research. And finally, the results are more easily influenced by the researcher's personal biases and idiocracies. Now that's something that you can read up. We only have a coffee break, I think. What's the plan? At 11, right? At 11. Are you still okay, or do you need a pause of 5 minutes, or is it we can carry on? What do you normally do? Carry on? All right. Okay. Are there any questions so far? Is there anything that you don't understand at all? I know it's a little bit theoretical. I try to give always examples. Good so far? Okay. So experimental research, true experimental design and quasi-experimental design. I'll give you a little bit of an exercise afterwards. Efficacy and effectiveness is important to distinguish when we talk about experimental designs. Are designs, are the result effective? Are the effective or efficient? Okay. Now, what's the difference? The efficiency or efficacy is the benefit of an intervention compared to a control or standard program under controlled randomized conditions. So randomized controlled trials, RCT design is often used. This is how efficient something is, okay? I come back to the result before. You're the control group, you're the a treatment group. How efficient do you respond to the treatment that I give you relative to the control group, okay? Now, effectiveness is a little bit different. It's the benefit of an intervention under less controlled real-world conditions. And this is the quasi-experimental design. And we're going to talk about these differences now. So we've got type of designs in this, and we're talking about a true experimental design here. Okay, so this is something that you might be doing in your hospitals or in your surgeries. And to understand the principle, we start with the one group post-test only design. For example, I test you after this day, and this exam after this day gives me a result. But I don't know what you really learned. I only know that you reproduced something that you recently learned. I don't know if I had done something else, for example, a pre-test and a post-test, I would know how you learned, how effective, okay, and how efficient both the treatment was. So this is important that we understand. We've got the same group before and afterwards, and in the meantime, this is the program, okay, or the intervention or treatment. We call it whatever you want, okay? This is, unfortunately, I would say, probably never the case in the hospitals or surgeries that you have and you're working in. Because who deals with healthy people that have no orthopedic problems? Is there anybody who treats healthy people that have no problems? No, Would you wish that? Sometimes? What would be the advantage? Hold on. What would be?
With the advantage of treating healthy people.
Yeah.
Treating maybe not, but
Seeing them. Well, you've got your basic exams. You know, you lift the leg and see how flexible these are, and see. Okay, that's a healthy person, you can say. Okay, same thing with shoulders, with neck motions, and so on. So if you were to do that with apparently healthy people, okay, you would see how healthy they are actually with their joints and so on, and the mobility, okay, relative to the what they claim sick people, okay, and then you would maybe see that there is not really two groups; it's one group, okay. Some lean a little bit more to that side, some lean a little bit more to that side, but there's a big in between. They have no problems, but have restricted mobility. The other people have way more flexibility, but they have problems. Okay, so this is a general problem of a study design. So therefore, we would need to have treatment people treated before an intervention and after the intervention. But this is in medicine actually never the case, because we don't come and see doctors and then get infected and then we come and see you again. Or we don't go to you before the accident and then to see what the treatment does after the accident, okay? But in a scientific study, this can be done. Okay, for example, if you were to treat people that have problems or have no problems, or chiropracticians, they do that quite often. For example, with sportsmen, tennis players, okay, they do some adjustments somewhere in the body, and they try to see before playing tennis, after playing tennis, or golf, or whatever activity they do, running, they try to see if they need adjustments, they don't need adjustments, if the amount of adjustments they need can improve their mobility afterwards and so on. So this can be done in a trial, in a study. This can also be done in orthopedics. But in general, this is a problem. So only if you do a research design, and this is what we must do, a pre-test, a treatment, and a post-test of the same population. The same population, okay? Oops. Yeah, that is what we would expect. So we would expect the pre-treatment is that the pre-test has got this result. The post-test has got this result. Okay, so we would see a desired outcome. The desired outcome should improve, should be higher than the pre-treatment. So that's the treatment. Okay, so we've got a treatment, and we would expect there is a higher outcome. Now, this needs to be seen also with a control group. Okay, if a control group has also an increase between pre and post, although they didn't get any treatment, okay, then what is important is that this here, the difference between that line and that line is double, but that's not the effect. That is not the effect. The net effect is only relative to how the control group fared. Right? Okay? So this is really important. So we can do a pre-treatment before and a post-treatment afterwards and measure the effects. But we must also take in a control group people examine before and after. And if the people that, as we said here, fared better, okay, then the net effect of the treatment is not the difference between before the treatment and after the treatment, but with respect to the control. Okay? So we describe that as a gross effect and net effect, but the net effect is scientifically relevant. Okay, so the experimental design is characterized by three experimental designs. Subjects are randomly assigned to at least two comparison groups. The purpose is to compare two or more groups that are formed by random assignment. The groups differ solely on the basis, this is very important, the group differ solely on the basis of what occurs between measurements, so the interventions, and most basic is the pre-test, post-test control design. That here, okay? So we need also a control group. So whatever we do here, okay, a treatment before and afterwards, we would need a control group as well. Okay, with people, that is always difficult because we can't clone people. We have always to use a different group. So if we were to test your knowledge before this course and after the course, okay, we would need to do the same thing with the same amount of people, same profession that did not go to the course, test them before and afterwards. It is likely that the people didn't understand more before or after, but we don't know. So this is what we call the net effect, okay, of the course or of the intervention. Okay. Well, that's what we said right now. The strength of the experimental design is controls the influence of confounding variables, providing more conclusive answers. Randomization eliminates bias due to pre-randomization confounding variables, and blinding the interventions eliminates bias due to unintended interventions. All of these experimental designs can be costly in time and money. Many research questions are not suitable for experimental designs. We talked about that before. Usually reserved for more mature research questions that have already been examined by descriptive studies and experiments tend to restrict the scope and narrow the study questions. So you can read that in more detail then later on. So what is a quasi-experimental design? Does not use randomized assignments for comparison. For example, a study was designed to examine the effect of electrical stimulation on passive range of motion of wrist extension in 16 patients who suffered a stroke. And I bolded this here, okay? Again, a study was designed to examine the effect of electrical stimulations on passive range of motion of wrist extension in 16 patients who suffered a stroke. The outcome, effects of treatment on sensation, range of motion, and hand strength. Patients were given pre-test and post-test measurements before and after a 4-week intervention program. Note, no randomization and no comparison group. Why can't we do that? Because we restricted these patients to patients that suffered a stroke. Okay, so we cannot do a control study because we can't control people that suffered a stroke twice. Okay, and these are the things that you can read up then again. We are a little bit behind schedule, but I think we are okay. Let me just see the schedule now. Okay. Are there any questions regarding the research designs? It's very complicated. I know it's lots of information. It's not very juicy to listen to, but